Find the emitter current, emitter voltage, base voltage, collector voltage, overall voltage gain, assuming that collector current is approximately equal to emitter current. Also determine the output collector voltage. This is the circuit. Now, the DC equivalent of this circuit is this one. To find the emitter current, emitter voltage, base voltage, and the collector voltage, we must find first the Thevenin's resistance. To find Thevenin's resistance, R1 is parallel to R2, which is this formula. R1 times R2 is equals to R1 plus R2 which is 47 kilo ohms times 10 kilo ohms over 47 kilo ohms plus 10 kilo ohms. The RTH is equals to 8.25 ohms. Second is to find the Thevenin's voltage. Formula R2 VCC over R1 plus R2, which is 10 kilo ohms over 47 kilo ohms plus 10 kilo ohms times 10 volts, which is the power supply. The answer is 1.75. Now, the total RE is equals to R1 plus R2, which is 940 ohms. To find the emitter current, equation is Thevenin's voltage minus the base emitter voltage over the total emitter current, emitter resistance plus Thevenin's resistance over the beta DC circuit. So, ang kuan 1.75 volts minus 0.7 volts over 940, which is the total emitter resistance nara. So, 940 ohms plus 55 ohms is equals to 1.06 milliamps. Now, to find the emitter voltage, equation is emitter current times emitter resistance 1 plus emitter resistance 2, which is equals to 940 times 1.06 milliamps. The answer is 1 volts. Now, to find the VC or the collector voltage, formula is VCC minus collector voltage times the collector resistance, which is 4.7 kilo ohms, and then the collector resistance is equals collector current is equals to 1.06 milliamps, and the VCC or the power is 10 volts, which is equals to 5.02 volts. Now, AC equivalent circuit of this circuit, equivalent circuit AC niya, alternating current is this one. So, first, para makuha nato si overall voltage gain, we need to find RE, which is equals to 26 millivolts over emitter current, which is equals to 1.06 milliamps equals to 24.5 ohms. To find the total input resistance of the base, what I mean is the base input resistance, which is equals to beta times RE plus emitter resistance 175 times 24.5 ohms plus 470 ohms, which is equals to 86.5 kilo ohms ang base input resistance. Then dinhidayon is ang total input resistance, which is R1 parallel to R2 parallel to base input resistance, which is 47 kilo ohms parallel to 10 kilo ohms parallel to 86.5 kilo ohms. The answer is 7.53 kilo ohms. In the attenuation, formula Vs over Vb or equals to Rs plus total input resistance over the total input resistance, which is equals to 600 ohms plus 7.53 kilo ohms over 7.53 kilo ohms, which is equals to 1.08. To find the collector resistance of the AC circuit, here is the formula: RC parallel to RL, collector voltage parallel to RL, which is 4.7 kilo ohms times 47 kilo ohms over 4.7 kilo ohms plus 47 kilo ohms, which is equals to 4.27 kilo ohms. Now, the voltage gain from base collector, which is base collector voltage gain, which is equals to RC over emitter resistance 1, which is equals to 4.27 kilo ohms over 470 ohms, which is equals to 9.09 volts. And then the total overall voltage gain, which is VB over VS or times AV, which is this one, 9.09. So 1 over 1.08 times 9.09 is equals to 8.45 ang overall voltage gain. To get the output collector voltage gain, we need to find the collector voltage AV, which is ang katong kuan ganina kaning siya 9.09. What I mean is ang iyang kani 8.45 iyang overall times the VS, which is 10 millivolts nga iyang power supply sa alternating current circuit, which is equals dayon siya sa 84.5 millivolts. Now, to find the max collector voltage, peak max collector voltage, which is equals to VC DC current plus 1.414 VC AC circuit, 5.02 plus 1.41485 M. Mo din ang answer dayon nato dayon nga 5.14 ang iyang maximum, and then the minimum is 4.90. Now, to get the V out or the output collector voltage, we have the formula 1.414 VC AC circuit. Collector voltage sa AC circuit, which is 84.5 millivolts. Now, ang atoang output collector voltage is equals to 119 millivolts.